So hello guys, welcome back to the another video. So in this particular video we will talk something interesting. Okay, so maybe you have heard this question in the interview. Interviewer will ask you to draw the boost converter and he will ask you remove the load and tell me what is the waveform of the capacitor voltage. So this kind of question will generally come in an interview. So in this particular video we will talk about what is the waveform of the capacitor voltage as well as capacitor current without load in the buck converter, boost converter and buck boost converter. So let's get started with this video. So before going for without load, let me tell you that what is the waveform of the IC, capacitor current with load. So if you have a misconception in your mind that the capacitor voltage VC, capacitor voltage VC will be constant, right? So this thing is perfectly fine in your mind. So if this concept is there in your mind that capacitor voltage will be constant when load is connected, so that is correct. What about the capacitor current? So if in your mind, if you are thinking that capacitor current will increase, then decrease, then increase, if this concept is in your mind for any DC to DC converter, if you are thinking that the capacitor voltage will be like this, then you are wrong. So this is not the waveform always for capacitor current. So you have to start analyze the circuit. So this is not the thing which is always correct. Okay. So what is the waveform? So whether this is wrong or right, this is partially corrected. So it is not always true, it is not always false. Okay. So it is partially true. So yeah, this is waveform is correct for the buck converter. But what about the boost converter and buck boost converter? Whether the waveform remain the same or not? Have you observed this thing previously? So if you have observed this thing, then you are on good analytical track. But if you have don't, then you need to learn how to analyze the circuit, what waveform it should have, everything you have to learn. Okay, so now we will see first that what are the waveforms when load is connected. Mostly I will talk about IC because VC remains the constant, right? So what is the waveform? So firstly we will see about the buck converter. So what is the waveform for the buck converter? So yeah, you are right, it will be gradually increased and then decrease, then increase, then decrease. So when a switch is on, it will increase. When switch is off, it will decrease. So this kind of waveform nature have for the IC when buck converter is there. Now second thing is when load is connected and it is a boost converter. So what is the waveform nature? So just try to analyze the circuit first. You know how the boost converter is, and if you have draw the waveform correctly, then you are on good track. But if you don't know, then you should learn. So what is the waveform? I will show you. So this kind of nature the boost converter capacitor current has. Initially when switch is on, it is some constant value, negative constant value, and when switch is off, it will suddenly rise and then it will gradually decreases, and when switch is again on, it will fall down to one negative value. So this kind of nature basically capacitor current have when it is a boost converter. Now the same thing when it is a buck boost converter. How is the nature? Just draw the circuit of buck boost converter, try to analyze it. If you have guessed the waveform correctly, then it is very good feeling for you. I will show you, that's for sure. And this video motto is to show you the waveforms when load is not connected, right? But why I am empathizing on this, because if you don't know, then at least you should learn something from this video, right? So what is the waveform of capacitor current when it is buck boost converter? So the nature is like this. Initially when switch is on, it is at some higher value and it will gradually start decreasing. When switch is off, it will suddenly fall down, it will come some negative value and it will be gradually increasing, right? It is increasing, and then again when switch is on, it will at its peak value and then again decreasing, and then this kind of cycle will have, right? So this is the three waveforms I have shown you when load is connected, and what is the value of the capacitor current, what is the waveform of the capacitor current when the load is connected. Okay, so you should know this thing. If somebody interviewer will ask you draw the capacitor current waveform for the buck converter, for the boost converter, so you should confidently draw this waveform. Okay, now we will go to the MATLAB and we will demonstrate basically when load is not connected, what are the waveforms. Okay, so I will just quickly open the buck converter circuit. So this is the MATLAB for the buck converter. Maybe you are familiar with this. Okay, so I have my DC supply. I have considered the 100 volt as a DC supply for buck converter, boost converter, as well as for the buck boost converter. I am giving the pulse as a 40%. So what is expected output, I will see here del into the Vin, that is a 40 volt. My expected output is 40 volt, right? Then how to calculate the L value, how to calculate the C value, this thing you have already learned. Okay, I have already discussed this in my previous playlist. Okay, so I will just simulate this and we will see what are the different waveforms will come. Now in this time load is connected. Okay, so I am running the simulation when load is connected. Now just see the waveforms what I am going to get. So okay, yeah, I am saying you the 40 volt will be the output, so nearly 40 volt is the output, right? Then if I talk about the inductor current, so inductor current is also nice. So an output current is almost constant, okay, with some ripple. Okay, so this is not the thing right now I am very much interested in, because what I am interested in, VC and IC. So when load is connected, you know what is the waveform. So I have already told you. So this is my VC. So VC is a constant, which you already know. When load is connected, VC will be constant. What is the nature of the current? What is the nature of current? IC. So IC, you see, whatever you know, the same kind of waveform will come. The same kind of thing I have shown you, right? So the same circuit you will see, it is increasing and then decreasing, increasing, decreasing. So the same thing whatever we have learned, the same thing is there. So when load is connected, now what I am going to do, I will remove the load and we will see what effect it will cause. So I am just remove the load. Now I am very much interested to know what is the waveform of VC and IC, right? So I will just simulate it. This is we are doing for buck converter. Okay, I am simulating it. So it will simulate and you will see what result will get. Now first we will see the output and all. So what I am getting here, just see. So it is basically almost 0. So my IL, inductor current, is 0. Okay, my output is continuously on, that is 100 volt. This is the voltage across the capacitor, it is almost 100, it is constant, and my output current will be definitely 0, because basically no branch is completed, so the current can't flow there. But you have seen one thing, output is 100 volt. Whatever the input I have given, the same is reflected in the output when load is not connected. So this voltage it is considering. So this voltage is nothing but the capacitor voltage, right? Whether I am right or wrong, this voltage is nothing but the capacitor voltage. Let us see the figure of the capacitor voltage. So this thing you know. Now we will see the capacitor voltage and capacitor current. So what I am going to get, just see once. So when it is a buck converter, so I am getting the 100 volt constant output. So and the same V out we are going to see. So the same waveform is here, and current, what is the current value? So current is 0. So keep this thing in your mind that when it is a buck converter and when we remove the load, whatever input we are applying, the same input will be appear to the output capacitance value, and current is going to be 0. So this thing you should keep in your mind. Okay, so this is about the buck converter. Okay, now we will next see the boost converter and similarly the buck boost converter. So there maybe we will see some changes, and what are those changes and all we will see. So now we are here in the boost converter simulation. So you can see that boost converter simulation. So boost converter circuit I have just drawn, and the same input 100 volt I am going to give, and my pulse is again pulse. How much pulse I am going to give? Pulse is a 40%. So what is the output I am expecting? Nearby 160 volt, 166 something output will become. You know D, what is the V naught by V in? 1 upon 1 minus D for the buck boost converter, right? So with load, initially I am going to simulate, just see what is the result, and then without load we will see. So just see this, what is the values and all. So whatever the output voltage I am going to get, so it is nearly coming 166. So the same using the formula also we can calculate, right? The same thing is coming here, 166 nearby. So that is fine. And inductor current, output voltage. So these things are also coming, and they are not equal. Why? Because inductor current is not the output voltage, output current, right? because this is a boost converter configuration. Inductor is at the input side, right? Whatever you have said, it is right. So this is the nature. So this thing we already know. Now see the effect of a capacitor current and capacitor voltage when it is a boost converter. So you can see here what is the value of the capacitor voltage. So capacitor voltage is again 166, because whatever be the V0, that will be the my whatever be the V0, that the same thing is my VC, right? So that is the same thing we are getting. Nearby 166 is my average value. Now what is the nature of the current IC? I have told you and I have shown you, right? So just I will zoom it and show you one more time that what current I am going to get. So just see here what I am going to get. So the same thing. Initially this waveform will start from here, not from the top. Okay, just don't get confused, because it's working is like that. It is nearby steady state waveform, that is why it is showing like this, but it is not like that. Okay, just I will show you, just wait a minute. Just I wanted to zoom it a bit. So how the waveform is? So waveform is like this. So initially it is at some negative value, then it will go high and then bit of decrease and then again come to the negative value. So this kind of VC we will get. Okay, and this nature we have already seen in the PPT, right? Now we will come to the load removal. Now I will remove the load. Now we will see the magic, what exactly the waveform we will getting, right? So just I am running the simulation. First we will see the what is the output I am getting and all, and what is the IOT, IL. So just see this particular thing. So you can see now that output is getting increased. It is suddenly increased to 300 volt and then it is increasing. Okay, my current in both the cases is almost zero. Here also the zero, IL also zero, and I not also zero, right? So now we will see the VC. So this question will come. So this is very important question. When the boost converter operate without the load, its value is suddenly increased to very high value, and it is keep on increasing. It is keep on increasing in the ramp fashion. So you can see that. Look at the waveform. So you will see the out VC is going to be increasing and increasing. It is keep on increasing, and maybe it will damage the capacitor. So that is the question generally people ask you. And what about the capacitor current? Capacitor current is almost nearby zero. Okay, it is a bit of you can see the nature also. So this kind of nature, they may ask you, if they want to ask you some difficult question, they will ask you what is the waveform of the capacitor current in the boost converter when no load condition is there. So this is kind of waveform it will get, right? So you just keep this waveform in your mind. Maybe somebody asks you in future, so you can answer this. Okay, so this is complicated kind of nature, and very less current it will draw. Okay, this thing also you should keep in your mind. But what generally interviewer will ask, what is the nature of the capacitor waveform? So capacitor voltage waveform will be increasing. You can see it is increasing, and if you zoom it, it will be like a sinusoidally, it will just keep on increasing. So you should tell this, that sir, this is the nature of the waveform, and if you zoom it, it will be sinusoidal in nature. Just see this, right? So you can answer perfectly, so that he will understand, right? So I hope so you have know that from now, that when the boost converter is operated without the load, its waveform is output capacitance waveform is basically voltage, output voltage capacitance is increasing and increasing till it has reached its particular something value limit, and maybe it will burn, or it will, because it don't have any discharging path now. Okay, till it will completely charge, so it will continue, right? So this is the case which is we have explained here. Now we will do the same thing for the buck boost converter. Now important thing for buck boost converter, similarly the same, I have applied the 100 volt and a pulse of 40%. Okay, now I will run it. So nearly 66 volt I am expecting my output. So just see the what output I am getting and all. So it is negative. Why? Because buck boost converter is a always give the negative output. This formula you know, right, that V naught by Vin is minus D upon 1 minus D. It is inverting in nature. So you will see the output is nearly 66 roughly. So it is minus 66. So that is fine, because we know using the formula this will come. Now inductor current, inductor current is also always as it is increasing, decreasing, right? And this is my output current. Output current is again negative. Okay, why? Because you know the reason. Okay, I'm not going into the buck boost converter operation principle here, that why current is negative, why output voltage is negative. So this thing, you know, these are the basic things. Okay, I am very much interested to see the capacitor current waveform here, because capacitor voltage will be constant, that thing you know. Okay, the same thing, the capacitor voltage, again whatever be the V0, that will be the VC, right? So when load is connected, right, when load is connected, so the same waveform is there. And what is the nature of the current? So current, again, that is important. Current is the key. Current you should know, I have shown you in PPT, right? So this the same thing, it will be start with some higher value, then decrease, and then when switch is off, it will come to some negative value, and then again some bit of increase, and then again goes. So this kind of nature it has, right? Now I will remove the load, and after removing the load, what is the effect? Let us see. Now I am running the simulation, just see the magic. So output, you know, I have already told you that IL and I naught will be almost, what is the nature, just see once. So when I simulate it, you are find out that V naught is decreasing, it is keep on decreasing, 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 like meaning it is not decreasing. If it is inverting, then it is keep on increasing, increasing, right? But it is going to be decrease, decrease. Output is zero. What is the current? Current is my now uh, this kind of nature current has now. Okay, so you should know this nature. When buck boost converter operated without the load, what is the waveform of the inductor current? So this kind of nature it will have. And what is the nature of the if after removing the load terminal, if we have connected one voltage measurement, so how much, what kind of waveform it will show? So it will show this kind of waveform. Okay, now the same waveform we will get to see in VC also, because VC and V0 will be same. So you can see here that the value, what is the waveform of the VC? So VC is keep on decreasing, decreasing, decreasing till the capacitor is completely charged. And if we continuously turn on that circuit, maybe capacitor get blast, right? So this thing will happen. So you should know that in boost converter as well as in buck boost converter, in boost converter the waveform is keep on increasing, increasing. In buck boost converter, waveform is output capacitance waveform is voltage of the capacitance is keep on decreasing, decreasing, decreasing. And current waveform is like what? Some particular value. So this is some kind of waveform of IC. So you can look into it, that how this nature and all will come. Okay, so I just wanted to show you that how, what is the IC and VC will be look when it is what, when it is buck converter, boost converter and buck boost converter. So with this I will conclude this lecture. So thanks for watching, and hope so you have enjoyed this video and learned something new. So thanks for watching.